Hello Year 9, welcome back for another round of mathematics. It's a beautiful Saturday night here and I hope you too are enjoying the new cooler weather and the joys it comes to cozy up and do some mathematics tonight. So the first discussion we're going to have is about similar objects, and this is a geometry related exercise and it's about recognizing when objects are essentially the same but they're different sizes. So similar objects are the same shape, they look the same, but they're different size. They've either been blown up or made smaller. Same shape, different size. That's the concept of similarity. And for this lesson you need to be able to, well, recognize similar objects, understand what similar objects mean, and then use something called scale factor to find unknowns. So up here I've written, similar figures have the same shape but are a different size. They can be bigger or smaller. They're just the same shape. And I've got two strange looking shapes here. They are actually similar. One of them has just been turned around a little bit. So if we turn it around and blow it up a bit, you'll get that object over there. Now, how could I tell these are actually similar? Well, for that, you'd have to be confident that they've all got the same angles. I'd probably have to put some right angles in here to give some confidence that it's all correct. And all of them are basically the same. They have the same scale factor, what's known as scale factor. What that means is if I multiply each of these values by a certain amount, I should get those values. So those lengths multiplied by something, which we call the scale factor, should give us the lengths of all of them. How do we find out the scale factor? Technically, the text says that the scale factor is the image length divided by the original length. So in this case, you could say, well, the image over here, let's say we're taking this side that's opposite the side that's slanted, right? So if I was looking at this side, opposite the side that's slanted, I say, well, the image there is 12. The original length here, again, opposite the slanted side is 4. You get a scale factor of 3. The easier way I find to remember this, and I'm afraid it's somewhat more primitive, is to go, well, the scale factor is essentially the larger length divided by the smaller length. Now that's assuming you're comparing the same size, right? That's a larger length on the same side divided by the smaller length on the same side, and that consistently will give you it as well. So if I'm comparing this side is the equivalent of this side. Remember, it's the one opposite the slant. So I go, well, on the longer length it's 12, the shorter length it's 4. 12 divided by 4, I also get a scale factor of 3. Right? Now the idea then with scale factor is if I had any length on here, I could multiply it by the scale factor. I could multiply it by 3 and find the scale factor over here. On the other hand, if I had any length over here, I could divide it by the scale factor to get the value over here. So to summarize, you multiply, oh, by the way, sometimes you see scale factor simply written as SF, which I have no objection to given my name. Now we multiply by the SF to get longer dimensions, and we divide by SF to get shorter dimensions. So if I have a length here, I would multiply by the scale factor to get a length here. If I have a length here, I would divide by the scale factor to get a length over here. In most of your questions, they're going to say, these two objects are similar. and you can just assume they're similar from the start. But if you didn't, you need to be checking things like the angles are the same and you have the same scale factor no matter which sides you compare. In this case, if I did 12 divided by 4, I got a scale factor of 3. If I did 15 divided by 5, I got a scale factor of 3. If I did 9 divided by 3, I also get a scale factor of 3. So no matter which way you look at this particular situation with these shapes I put here, the scale factor is 3. Right? These are similar objects. They're the same shape, different size. All right, but remember, most of your examples are just going to tell you these are similar objects and work stuff out. And that's what the next example is going to be. I'm going to do an example of you're told that two objects are similar, find the lengths. So let's do that. By the way, the other thing that I'm not going to cover in the video today that can turn up is how to enlarge objects. So if you were told, use a scale factor of 3, make this thing 3 times as big as what it is, well, you're going to draw something like that, obviously not exactly that. If I was trying to make this 3 times as big, it's going to look something like that. But to do that properly, you would need to actually measure things, and there are some techniques shown in the text for how to do that. So if you ever want to, physically make this 3 times as big, there's instructions in the text on how you would do that. But for now, we're going to focus on scale factor and using scale factor, which is our main focus. So, I'm going to make 2 objects. I haven't quite decided what sort of objects I am going to make this time, but let's go for it. I need to make one kind of small. There we go, like a 5-year-old's depiction of a house. And for fun, I'm going to do the other one upside down. There we go. Now, I need to put some dimensions on that. I might make it, what do you reckon, 9 meters? I'll make that X, so we don't know what it is. Meters, and I'll make this 6 meters here. Might put those markings on it. Do you know what that means? It means they're the same. And I might make this 24 meters over here. No, or will I? Yeah, I'll make that 24 meters. I'll make this Y meters, so it's unknown. So X and Y are unknowns. Deliberately making some unknowns here so we can make this an interesting question later. And here I'm going to make it 42 meters. Now the sort of question that you'll get here is these objects are similar. So you can assume that they have the same shape, but obviously they're a different size. And from there, what they're going to do is go, 1, find the scale factor. You don't know what the scale factor is here. What would you multiply dimensions here by to get this one? Or what would you divide dimensions here to get that one? You don't know that. You don't know the scale factor, how much bigger that object is than that. We don't know that yet. So they can ask you to find the scale factor. And then they might ask you, and this is probably a bit predictable, to find X and to find Y. Right, so let's do that. Do we have a side that we can compare of these two? We do. This bit at the top of the house, we have its length in both diagrams. From that we can find the scale factor. Remember how I said it was essentially the larger length divided by the smaller? Well, the larger length was 24, the smaller was 6. What's 24 divided by 6? It's 4. So there you go. Your scale factor is 4. So for any dimensions that you have in the smaller diagram, you should be able to multiply by 4 to get the dimensions here. And for any dimension here, you should be able to divide by 4 to get the length over here. So let's do that. In terms of x is in the smaller side here. So x is going to be, its equivalent length over here is 42. It's the same side, it's just upside down. It's going to be 42 divided by 4. So it's going to be 10.5, and remember our units, it will be meters. So remember, divide to go to the smaller, multiply to go to the bigger. For y is the side here on the bigger diagram. Its equivalent over here is 9. So to go from the smaller to the larger, we multiply. So I'm going to do 9 times 4, our scale factor of 4. It will be 36 meters on this diagram. So guys, that will do for an introduction to similar figures. Similar figures again, same shape, different size. If you want to actually check if objects are similar, you really need to compare the angles and make sure that all sizes are comparable. They have the same scale factor, no matter which sides you compare with each other. And the bigger application here is being able to find the scale factor between two objects and use that scale factor to find values in either diagram. Have fun!